Hello friend, once again a colorful welcome to all of you. Today we are going to learn about dimension and error. So basically every physical quantities, almost every physical quantities have some dimensions. Okay, and we can represent any physical parameter by the dimensional equation ma m to the power a l to the power b t to the power c. Okay, so almost every parameters, physical parameters follow this equation. Okay, some dimensional, for dimensionless parameters the value of a b c are all 0. Okay, so let's take some example dimensions. Let's say area. We all know area is length square, so the dimensional equation will be a equal to l square. And there are more volume, velocity, acceleration. They are all dimensional variables. Some dimensionless variables are like, you can say 1 2 3 pi, any constant. Okay, not all the constants, they are all dimensionless variables, so their dimensional equation will be like that. Okay, so the dimensional equation must be followed by third bracket. Okay, okay, follows that. And some dimensionless constant. Okay, sorry, dimensional constant. Generally we know constants are dimensionless, but here we will discuss about some dimensionless, sorry, dimensional constant. They are Planck's constant, and gravitational constant. We all know gravitational constant has dimension, Planck's constant has dimension. From the equation we can find out those. Okay, we are not going to that, later on we will find out on later chapters. And some dimensionless variables, more important. Okay, the parameter angle, you know, angle, solid angle. Okay, they are all dimensionless parameters. But the significance about angle and solid angles, they are also called supplementary units. Supplementary units, because although they have dimensionless, but they have some units. Okay, angle has radian and solid angle has steradian unit. So what is the importance of dimension? Generally it is used to easily check a physical equations. Suppose we say the equation of energy, kinetic energy is half mv square, and the equation of potential energy is mgh. So they are both a form of energy. So this is the, although we write it k and we write it u, but their energy, so their dimension must be same. Okay, so to check it we can compare their dimensions. So if that satisfies, that means that equation satisfies, then we can say that they are valid, they are both are energy. Okay, so that is the easiest way to check physical equations. But there is some limitation as well, because from dimension analysis, or from the dimensional equations, we cannot derive a composite equation. Suppose, what is composite equation? We all know v equal to u plus at, right? Uniform motions equations. Okay, so we cannot derive such composite equation. We can easily derive that equation from dimension, but we cannot derive that equation. That is one limitation. And one more things, if there is some constant, dimensionless constant. Okay, suppose force is a is relate to k, a and b, where a and b are have dimensions, some finite dimension, but k is dimensionless constant. So from dimensional equation or dimensional analysis, we can find out the AB. and with sufficient condition, but we cannot find out exact value of k. That is one more limitation. Okay, so that is the dimension. Okay, I think that is okay for the chapter dimension, and there will be later I will discuss about the application part. Okay, on my later videos I will discuss and analyze more details and with more numericals on my next few videos. Okay, first let's cover the theory part. Okay, and it is up to that theory part. Now we will move to error analysis. Okay, so error analysis, we all know what is error. We can say it is some form of mistakes. Okay, so if we perform any types of experiment, there must be some mistakes, so there must be some errors. Okay, so generally in reality we have to avoid such errors. So to avoid such errors we have to familiar with the errors, right? So before familiar with the errors, let's discuss about some important parameters as well. So first comes significant numbers or significant digit. Okay, so significant digit. So what are significant digits? The digits whose values are correctly known for a particular measurement. Suppose you are measuring the height of yourself. Okay, so if you say it's 1.5 meter, your height is 1.5 meter, and your friend measure it 1.52 meter, and your mother measure it 1.5 to 5 meter. So then we can say this value is less significance to this value. So your mother is more accurate while measuring your height. So from that value you can say there are 4 digits which can accurately measure your height, and there are 2 digits which can accurately measure your height. So this has 2 significant number and this has 4 significant numbers. Okay, so there are some rules to find out significant digit or significant numbers, whatever you say. Okay, so generally we'll try to express those rules or those rules using some examples. Okay, suppose let's take some non-zero digit. Okay, 1 2 3. So when it's a non-zero digit, then all the non-zero digits are significant. 1 2 3. So there are 3 significant digits. Now what if we put a 0 before that and we put a 0 after that? Then also the number of significant digit will be, or significant figure will be 3, because a 0 before a non-zero number, okay, not in decimal form, a 0 before a non-zero number is always insignificant, and a 0 after a non-zero number also insignificant. Okay, another rules, okay, another rules I think. But yes, one more thing, if those zeros appears in between these non-zero numbers, suppose like that, okay, then the number of significant digits here all, because the zeros in between non-zero numbers are all significant. Okay, so the number of significant figures is 1 2 3 4 5 6 7. So what if we consider some decimal points? For decimal point is similar, 108 1007 okay, for that also all the zeros in between non-zero numbers, so 1 to 3 to 5 to 7. Here also significant digit is 7. But what if the number is like that, 0.00123? Then the significant number will be, or the significant figures will be only the non-zero numbers, because it start with 0 before decimal point, and the zeros if starts with 0 and all the zeros before non-zero numbers, then we can say they are not significant. So only the non-zero numbers will be significant. So the non-zero number here will be 3. Okay, but what if such case appears if 0 0 1 2 3 0 0? As in the previous example we see that the 0 before a non-zero number in case of decimal point is insignificant, but in case of decimal the zeros after the non-zero numbers are significant. Okay, that you have to memorize or you have to consider it. Okay, that is the important part. So here the significant number or the significant figures is 5. Okay, and one more thing, another rule, I just forget it. Okay, yes. So in previous example we saw 0 after a non-zero number is not significant, but what if the number is like that? After that 0 a decimal point is given and another zeros are given, then all the 0 will become significant. Then the total number of significant numbers will be here 1 2 3 4 5 6 7. So by using underscore I am just indicating the significant figures or significant numbers. Okay, so why significant numbers is important I already told you. So okay, one more thing, these are for theoretical. Suppose you are given in a questions and you have to ask the significant figure, but if experiment shows, suppose a practical experiment, from a practical experiment a measured value is suppose 1020 meter, the length of something, suppose the length of a way. Okay, the length of a street of your locality is 1020 meter. Okay, so if you are given 1020 and asked to find out the significant figures, number of significant figures, then you will say the number of significant figures will be 3 because this 0 is not significant. But as it comes from a practical experiment, then you cannot change it. Then you have to consider all of the figures, either they are 0 or non-zero, they all are significant. So that number of significant figures here is 4. Even you can change it, you can say okay, I can write it like that, 10 to the power 3 meter, or I can write it like 102000 centimeter, right, or whatever you want. So the figures will be changed according to the rules. Here are the rules, but as it is figured out from a practical experiment or practical measurement, okay, or experimental measurement, you cannot change the significant figures. Okay, we have to consider the actual values. Okay, now comes to rounding off. Okay, let's comes to rounding off. So what is rounding off? We all know, if there is a number like that 15.3, okay, so we can make this 3 to 0, just we can write it 15, and if it is 15.7 we can write this number to 16. How? Actually we say if the last digit is 5, sorry, the last digit is greater than 5, then we can increase the previous digit by 1, and if it is and if it is less than 5, the last digit of a number is less than 5, then we will decrease the number by 5. So already here the last digit is 3, which is less than 5, so we decrease it, we decrease this 3, okay, and sorry, not -1, actually we will retain the digit, okay, we will not do anything, we will just omit the digit and retain it to 0 or something like that, okay, 15.0 actually, and 15.7 to 16. And if we and what if the digit is like that, 325 326.5, the digit itself, the last digit itself 5, then we will consider the previous digit of the last digit. If it is 5, then we will see the previous digit. If this digit is odd, sorry, even, then this will retain to 326.0 or only 326. But if this digit is odd, suppose like that, 323.5, then it will be increased by 1. So this 5 will be omitted and this will be 324. This digit will be increased by 1. So why we are considering rounding off? Because if we perform some arithmetic operations with over some different significance figures number, so to get the result with proper significant figures, or to maintain the proper significant figures, we will using the concept of rounding off. Okay, so let's take summation. Sum. Let's take any number 1, 2, 3, 4.5. Another number is 1, 2.34. So in case of summation, we will consider the result. So first check the result, 48.6421. It will be the mathematical result. But using the significant figures, you have to find out the result according to the significant figures. Then what will you have to do? Then you have to you have to maintain the result with the number having least decimal point. So there are two numbers, 1 2 3.4.5 and 1 2.34, right? So this has less decimal point, so we'll take the number to less decimal point. To make it less decimal point, we'll rounding off. So here is 1 decimal point, there is 2 decimal point, the answer is 2 decimal point, so we have to make it 1 decimal point. Okay, so to make it 1 decimal point, we will rounding off. So here it is 4 less than 5, so it will be rounding off to the answer 1246.8. That will be the correct answer. Okay, and one more way you can say that why we will just make the result rounding off. Why not we will just rounding off the adders. Okay, first. So here you can say, okay, 1 2 3 4.5, here are 1 decimal point, then make it rounding off, 1 2.34, 1 2 point. Now 4 is less than 5, so it will retain to 3. So that will be sum to 8. Let's check the values, they are same. So you can get both the way, both are correct. Again same for difference. Okay, wait. Okay, same concept for difference. You can say 1 2 3 4.5, 1 2 3 4.5 and 1 2.34. You can subtract it and you will get 1 2 2 2.16, and if you after rounding off you will get 1 2 2.2. Why? Because 6 is greater than 5, so this digit will be increased by 1 and you will get 2 here. Another process, 1 2 3 4.5, and it is just a lightning. Don't worry guys. And the number is okay, let's rounding off this number 1 2.3 because 4 is less than 5, so let's differentiate or subtract it. So 5 minus 3, 2, 2, 2, 2, 1. Let's check that the result are same, identical. So don't bother about that. Okay, just follow any of them. You can just first you can make rounding of this. Sorry, you can just sum this and then rounding off, or you can just first rounding off then sum this. Okay, any of the way is correct. Okay, but you have to consider that the result must be like that, least decimal point. Least decimal point. Okay, you have to consider it in mind. Next come to multiplication and division. Okay, they are same almost, but there is some twist. What is the twist? Let's take the number 5, 6 and 7, 8, 9. Let's take it. If you multiply it, okay, if you multiply it, then you have to maintain the least number of significant figures. So in between two numbers, it has 3 significant figures, and it has 1, 2, 3, 4, 5, 6. 6 significant figures. So after multiplying, you have to make the result such that the result must contain 3 significant figures. Okay, let's take the help of calculator. Okay, 1, 2, 3, 4, 5, 1, 2, 3, 4.56 into 78.9. Okay, so the result will be like that, 97.406.784. Okay, so here you see the result is having 1, 2, 3, 3, 6 to 8. 8 significant figure. So what will you do? Check from left side. You have to make 3 significant figures. So 1, 2, 3. 1, 2, 3. So the right of them you have to make it insignificant. How can you make it insignificant? You can just rounding off the answer. How can you rounding off? You all know this 0. After that it's 6. Does not matter. After 4 it's 0, which is less than 5. So we can retain the value. So we can retain the value like that, 400.000. Or you can say it's just like 97400. And what I said on the previous pages, the zeros after any non-zero numbers are insignificant. So the total number of significant figures here 3.